So today in this video we are gonna do one shot for maths. So let's start with set theory. So in this video I'm gonna just touch upon the topics. Uh, for the people who have already done these things, this video might serve as a revision video, and the people who haven't done this, they'll also be able to follow because I'm gonna touch upon only very important major topics, and I would like to keep this video as short as possible. So without further delay, let's get started with our very first topic, that is set theory. So set, you might already have heard of set. Like I would like to start with a very vague example. Let's say a dinner set, or let's say like sofa set. All these things are set. But in mathematics, sets means like a collection of well-defined objects. Collection of well-defined objects. So in maths, for example, if I will write like the outcomes of tossing a coin, there are two outcomes, na? Head and tail. So, what do you mean by well defined? Is like if you will ask a person named Anita to write the set of outcomes when she will toss a coin, then her answer will be this. If you will ask me, I will also say head and tail. My answer will be this only. If I will ask you or somebody else, their answer will be this. It means the set doesn't change uh, no matter what whom you are asking to write the set about. So let me tell you an example of non-set. If I'll ask you write a set of most dangerous animals in the world. So it is not a set. Why? Because for me, dangerous animal might be tiger, cheetah, or like lizard, maybe. But for you, the dangerous animals ka set will be different. Or because it is the set is going to change, uh, and it depends to whom you are asking the question. Means it is not same, so it's not well defined. Since this set is not well defined, we won't consider it as a set in maths. So in maths, we call set as a collection of well defined objects, right? So let's move on. Now, I won't spend much time on like more things regarding sets, but let me tell you briefly about power set. So what do you mean by power set? Say if I have a set like 1, 2, 3, and 4, if and there is one more thing named as subset. So what subsets could be formed from this set? 1, I can write this as a subset, I can write this as a subset, I can write this as a subset, and I can also do this 1, 2, 3, 2, 3, 4, right? And 1, 3, 4. There are many possibilities of like get extracting several sets from this, like 1, 2, 2, 3. There are many more, na? So maximum number of sets, that subsets that can be extracted from this particular superset, अगर मैं उनका भी एक set बना दूं, then this will be named as power set. Okay, so let me there is a very important formula you should write. Number of all subsets of a set. This is 2 to the power n, where n is the number of elements in the set. Say here are 4 elements, na? So 2 to the power 4 means 16. There are total 16 subsets that can be derived from this set, and one subset will be 5. 5 means null. Okay. So there is one more term named, as I told you, number of elements in the set. This is what we call as cardinality. Cardinality of a set. If you like see somewhere it's written cardinality of A, like say it's A is equal to this. So cardinality of A will be 1, 2, 3, and 4. Got my point now? Yeah. Let's move on to the next topic. Okay. So now I will move on to intersection and union. So let's say there is a set A and there is a set B. So there will be some common, let's say A is 1, 2, 3 and B is 2, 3 and 4. So 2 is common between A and B. So I can write this like A, B. So 2 is common between both, and 1, 3 here, and 2 is also 3 is also common now. So we can write 3 here, 2, 3 and 4. Okay, so this portion that is common between both, this is what we call intersection. It is represented as A intersection B. And in the same way, if I have to like this whole thing now, A and B both, this is named as union. So there is relation between number of, you should remember this, number of elements in set A plus number of elements in set B is equal to number of elements in A union B plus number of elements in A intersection B. So you should remember this formula. Now I would like to give you a example question that has been asked in the previous year paper. Okay. So the question was asked in 2014. It was like a hospital has 35 patients. Let me write the question. A hospital has 35 patients, 24 of which are HIV positive and 16 have TB infection. All patients have at least one of the two infections. At least one of the both. I'm sorry for my handwriting. Infections. So the number of patients with both HIV and TB is, okay. So here what we have given is there are total 35 patients. Means there are total 35 patients and 24 of which are HIV positive. HIV positive wale are 24 and TB wale are 16. All patients have at least one. Matlab, every patient in the hospital have at least one of the infection. It means if I will say number of patients with HIV is 24 and the number of patients with TB is 16. Since all patients in the hospital have at least one infection and there are two infections discussed here, no? So we will assume like the union of HIV patients and TB patients is 35. And what they have asked us to do, the number of patients with both HIV and TB. So we have seen na, the intersection that is in both. So we will use this formula, this one formula, the formula which I showed you na, number of elements in A plus number of elements in B is equal to number of elements in A union B plus number of elements in A intersection B. So here I have to find the number of elements in A intersection B, means the patients with both HIV and TB. So how I will go about it? This was plus. So number of elements in HIV is 24 and TB is 16. This is plus here, so it will go that way, then minus number of elements in both, I mean the patients who are having HIV as well as TB. So when you will go about it, there will be 40 minus 35, means there are total 5 patients who are having TB as well as HIV infection. Okay. So there is one more question from the 2017 paper. So let me discuss that question as well. So they have given us, if P is equal to 1, comma 2, comma minus 1, comma 3, and Q is equal to 0, comma 4, comma 1, comma 3, and R is equal to 1, 6, and 7. They have asked us to find P intersection Q union R. So how I'll go about it? Q and R. First, let me write Q union R. It means I have to write the elements only once. 0. First, I will write this. 1 I have already written, so I won't repeat. 6 and 7. This is the Q union R. So I have to find the intersection between P and this set. So what is common between these two? 1 is common, 2 is not there, minus 1 is not there, 3 is right. So the P intersection Q union R set is 1, 3. Right? Okay. So there was one more question in 2019. Let me write that question as well. So they have given us a universal set that is 1, 2, 3 up to 15. And they have said that let P is a subset of U and consists of prime numbers. It has prime numbers. Okay. And Q is a subset of U. It has even numbers. And R is a subset of U. And it has multiples of 3. Okay. So they have asked us to assume let P is equal to P minus Q. Then which of the following is correct? So we have to tell which of the following is correct. So option A, T is equal to 5. Cardinality of T union R is 9. B, C, let me write it fast. These are the options, right? So I have already told you what does it these like slashes mean. T intersection R. So the easiest way to do this is first write the sets as early as possible. So P are the prime numbers between 1 to 15. So what will be the P prime numbers? 1 is not a prime number. 2, 3, 5, 7, 9 won't be there. 11, 13. This okay. And for the even numbers, it will be 2, 4, 6, 8, 10, 12, 14. Okay. Multiples of 3, 3, 6, 9, 50. Okay, so this is R, this is Q, this is P. What is T here? Okay, T is P minus Q. So P minus, let me write T as well. P minus Q. This is P. This is Q. So P minus Q. P minus Q means I am not allowed to write any element of Q in P. So since 2 is there in Q, so I won't write this 2. 3 is not there, I can write 3. And 5 is not there, I can write 5 as well, 7 and 11 and 13. Okay, so this is T. So how many elements are there in T? 1, 2, 3, 4 and 5. There are 5 elements. So by this, B and D can't be true because cardinality of T is 5. So out of option A and C, one of this is true. So let me write T union R. So if I'll write T union R, let me change the color. So this is R and this is T. So if I have to write T union R, what it will be? 3 is common between them. 3, 5, 6, 7, 9, 11, 12 and 13. Okay, 1, 2, 3, 4, 5, 6, 7, 8. So, am I missing something? 3, 3, 5, 6, 7, 9, 11. Yeah, 15 I haven't written. So like 1, 2, 3, 4, 5, 6, 7, 8 and 9. So T union R, the cardinality of this set is 9. So option A is true. Let me check for T intersection R as well. So in T and R, there is only one element, that is 3, which is common between these two. So option C is also correct. Right? So now let me move on to the next question. Next topic. There are so many things to cover, but I just want to cover the majorly important topics. Not all things I'm going to cover. Okay, so let me do the quadratic equations next. Okay, the quadratic equations. So let's say if it is ax square plus bx plus c equal to 0, so I will solve this using this quadratic formula. X is equal to minus b plus minus b square minus 4 is c upon 2a. So if this is what we call as discriminant. So if my d is equal to b square minus 4ac is greater than 0, it can be less than 0 or it can be equal to 0. If it is equal to 0, then I will say the roots are equal, and if it is greater than 0, then I will say the real roots exist, and if it is less than 0 means it's negative. It means no real roots exist. Okay. So let me see if there is a P by Q. And also there is one more thing. Okay, let me tell you here. Actually, let me solve a question. Okay. If there is a question like x square plus 8x plus 12 is equal to 0. So if I have to calculate x, I will do this way. This is A is equal to 1, B is equal to 8 and C is equal to 12. So minus B plus minus B square minus 4 into A is 1, C is 12, 2 into 1, right? So minus 8 plus minus, so here it is 16 and 2, minus 8 plus minus 4 by 2. So minus 8 plus 4 by 2 and minus 8 minus 4 by 2. So minus 2, minus 6. So there are two roots. Two values of x means there are two roots. Okay. So let's call these two roots as alpha and beta. So now I'm gonna tell you a very important property. Alpha and beta means the product of roots of quadratic equation, and alpha plus beta means the sum of roots of quadratic equation. It was ax square plus bx plus c equal to 0. So the sum is equal to minus b by a and the product is c by a. So I will show you this with the help of the recent example which we have done, that is x square plus 8x plus 12 equal to 0. So the roots were minus 2 and minus 6, means alpha was minus 2 and beta was minus 6. So alpha into beta was c by a. It means let's this 6 2s are 12, so 12, and let me write c is 12 and a is 1, so this justifies. So alpha plus beta is what? Minus b minus 6, that is minus 8. Alpha plus beta was minus b by a, so what is b? 8, so minus 8 by a, right? So this justifies. Okay, if the roots are not real means they are complex. Okay, now let's move on to the another topic, that is sequence and series. Okay, so let's say I have a arithmetic progression, that is 2 4 6 8. So there is a difference of two elements. So the first element is called a and the difference is called b. I mean a2 minus a1 is 2. Similarly 6 minus 2 is 2. So when the difference between any two successive terms is the same, then we call it as AP. So let's say if I have to calculate the nth term of this series, let's say I have to calculate the 20th term of this series, how I will do about it? An is equal to a plus n minus 1 d. This is a formula you have to remember. So I have to calculate the 20th term. So a 20th is equal to a first term is 2 plus 20th term 20 minus 1 is 19 into d. D is what? 2. So 40 will be the answer. And if I have to calculate the sum of n numbers, so the formula of Sn will be Sn is equal to n by 2 2a plus n minus 1 d. So you just have to put the value of first term and the number of terms in the series. Like let's say if I have to calculate the sum of uh, first 24 elements in this series, then I will put n as 24 and d is the common difference between successive terms. And apart from this arithmetic progression, there is another progression named geometric progression. What happens in geometric progression is, let's say if I will write 2, 4, 8, so let me write it in this way, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the 16, and then 64, 32. Oops. So what we are doing here is, so there is a common ratio here, like this is a1, this is a2. So if I will do a2 by a1, so 2 to the power 2 by 2 is 2. If I'll do a3 by a2, that is 2 to the power 3, 2 to the power 2. So 2 is the answer now. So there is a common ratio. So we commonly write it as ar plus ar square and so on. Here the r is 2. So what if I have to calculate the nth term of this series? And there are also infinite series. So let me write for infinite series as well. Let's say if there are in like infinite terms in this particular series, then if I have to calculate the sum of this series, how I will do? This is a upon 1 minus r if my r is less than 1. But if it is greater than 1, then the sum of series will be infinite. And if I talk about finite series, then it is a 1 minus r to the power n upon 1 minus r. This is the sum of finite series. Let's say if I have to calculate the first the sum of first 20 numbers in the geometric progression, then I will put n as 20 and r is the common ratio, a is the first term. Let me tell you with the example shortly. Like 2 plus 4 plus 8, if I have to find the sum of first 50 terms. So the formula for the sum was 1 minus r to the power n, 1 minus r. So I will put a is 2, r is the ratio. The ratio is 2, na? The ratio is 2. So 1 minus 2 to the power 50 upon 1 minus 2. You will be having calculator there. So you can calculate it itself. Great. Okay, there is one more important formula, that is for the logarithmic series. Okay, so for the log series, the sum will be this if your series looks like this. And x is less than minus 1. Oh, sorry, x is less than 1. Nowadays, these type of questions are not coming as much, so you can skip it as well. Trigonometric formula, all these basic things I'm not going to tell. I hope you know the basic trigonometric formulas. So I will directly jump to the question that was asked in 2018. So they have asked us to simplify sin A upon 1 plus cos A. It was a very easy question. 1 plus cos A upon sin A. This was a very easy question because you simply have to take the LCM of this denominator. So cos A is already there, so it will be sin square A plus 1 plus cos A whole square. So what it will be, sin, so this A plus B whole square, that is A square plus B square plus 2AB. So sin square A cos square A is 1, right? And 1 is already there, that is 2. So 2 plus 2 cos A upon sin A into 1 plus cos A. So if I will take 2 common, it will be 1 plus cos A upon sin A into 1 plus cos A. This will be cancelled out, and as you all know that 1 upon sin A is cos A k. So 2 cos A k is the answer to that question. Okay, let me find some other previous year question if any. I will share these notes in the Telegram channel. There are so many things, but since we are doing a one shot, so I'm not expecting to cover everything. Okay, now this is important. Let's discuss about permutations and combinations. Permutations, just remember one thing, it's all about arrangements. So here order matters, means A, B is not equal to BA. So combinations is all about choosing something. Let's say choosing or selecting something. Let's say there are 10 apples, I have to choose 2 apples. What is the chance that I will choose these 2 particular apples from? If I'll choose A1 apple and A2 apple, it is equivalent to choosing A2 and A1 apple. So here in combinations, order doesn't matter. So the formula to calculate the combinations, to calculate the permutations of n objects is n factorial, n minus r factorial, and the number of combinations of n objects and selecting r objects is n factorial upon r factorial, n minus r factorial. So let me see if there is a p by q. There are many p by q's. So let me choose one. Hey, why I haven't written any previous year question? Okay. So in 2023, a question was asked the number of possible unique combinations of linear tetrapeptide that can be made from 4 different amino acids using each amino acid only once in the chain. So we have to like find the combination of different tetrapeptide, mean four like amino acids are there in a peptide, then we call it as tetrapeptide. So there are 4 amino acids present only. So in first position, any amino acid, we can choose any amino acid. And for second position, since we have already chosen one, so there are only 3 left. For the third position, only 2. And for the final position, only 1 is left. Na? So there are total 4, 4 3 12 24 like different unique peptides can be possible. Okay, now let's move on to the another topic. Sorry. Yeah, this is important. Now let's talk about limits. I would like to directly start with the previous year. There are few things that you should know. Okay. So limit of x tends to 2, x square minus 4 upon x minus 2. So if you will directly try to put 2 here, then 2 2s are 4 minus 4 upon 2 minus 2, that is 0 by 0, that is undetermined. So to solve this problem, we use the limits. And since we know that I can write this as x square minus 2 square upon x minus 2. Now a square minus b square can be written as a plus b and a minus b upon this. It will be cancelled out, and if I put 2 here, 2 plus 2 will be 4. So the answer to this problem is 4. Okay, so let's say if sometimes I don't and also there is one more thing. The limit of x tends to 0, sin x upon x is 1. This is a theorem you have to remember. Okay, so let's say for some time you are not able to find uh, even after using identity and all, you since then also your undetermined form is coming up. Then in that case, what you'll do, let me tell you with an example of from previous year question. At that case, you will use Al-Hospital's rule. So this was a question that was asked in 2023. So here we can simplify it to 2 can be taken as common. So x plus 3. 2 can be taken as common. So 2x plus 3 will be cancelled out. The answer will be 2 only. Here L-hospital was not applied. Okay. So let me see if I have any example here. Just give me 1 second. It's very strange. Okay, let me see if I can find a question. So this example is for demonstration purpose, how L hospitals rule work. So if I put minus 2 instead of x, then you will find that this whole thing is giving you an undetermined form, that is 0 by 0. So to avoid this issue, there is no identity that you can apply. So in this case, what you will do is you apply L-Hospital's rule. What L-Hospital's rule says, you differentiate the numerator as well as denominator. So if I differentiate x, then it will become 1, and 2 is a constant, it will become 0, and x square is differentiation of x to the power n is nx n minus 1, right? So 2x plus for this is 3. So now if I'll put x की जगह पे -2, then it will be -4 plus 3, that is -1. So this is how L-Hospital's rule work. Now let me quickly complete the probability. I hope you know the basic probability formula, that is the number of favorable outcomes by total number of outcomes. Let me tell you a little bit about conditional probability with an example. Okay. So the conditional probability is, say there is an event and you did something. Let me tell you with an example only. So let's say you are throwing a die and you get 6, right? Now you get 6 and there are actually 3 dice. First you have to choose a die and then you have to throw that die and see what number comes. So if I say you that what is the probability that what is the probability of coming up 5 on throwing a die if you select the third die. So there are 3 dice. First you have to select a die and then you have to throw and see which number comes up. So what I'm saying, I'm giving a condition now, ki what's the probability of getting 5 if you choose third die. So the choice of third die has already happened. This is the condition. So how it goes about, uh, what's the formula that we are going to use? So whatever is the condition, we'll like give it as f. So let's say f is an event that has already happened. Means I have already chosen the third die. So if I have already chosen the third die, what is the probability of getting a event? Let's say uh, number 6 on the die, or like getting head or something, given that it has already happened. Just a minute. Yeah, so the probability of getting a like E is getting 5 on the dice and F is choosing a die. So what is the probability of getting 5 on the dice if I have already chosen the third die? You got it, na? Here it will be n. N means the number of times you get 5. So I will clarify this with the help of an example. It will be more easy. Okay, let me write it down quickly. A parent has 2 consecutive children. What is the probability that first are both boys, given that? So whenever you see given that, it means this is a condition that has already happened. At least first or second of them is a boy. Okay, so if a couple has 2 children, so what could be the sample space for this? So the sample space will be either they can get 2 boys, 1 girl, other boy, 2 girls, and 1 boy, other girl, right? So what is the probability that first and second both are boys? So dono both are boys. Both are boys means your event is this, both are boys, right? And what is given? The given is at least first or second of them is a boy. So what will be your given condition? First or second of them is a boy. Like the first place पे भी boy हो सकता है or maybe at the second place. Means one boy they have fixed. Okay, so the probability of having a boy given the first one of them is boy is the number of the number of elements in E intersection F divided by number of elements in F, since F is already happened. So like it is BB, no? This is a single element only, 2 boys. So 1, 2, 3. Here it's 3. Intersection is 1. So 1 by 3 means 33% probability that a couple will have 2 boys given 1 is a boy. This is conditional probability. Okay, so I will upload this notes on the Telegram channel. You can have a look. If you still have any doubt or concerns, you can always ask. So with this, I would like to end this video. I know I have little touched upon every topic. This was not in much detail, but since it's one shot, then it is supposed to be like this only. So with this positive note, I would like to end this video, and best wishes for your exam. I hope whatever I have taught you, it is gonna be helpful for you. Okay, best wishes for your exam.